Car accidents happen again and again. But when the body of the car absorbs the energy and redirects it, that is a good thing. It makes the passenger safer. Safety engineers have done a lot of work to ensure that vehicles can do this. And the results are worth looking at. Some components of the car's body have a high level of stiffness, and others are softer and designed to bend. Some even have both properties, stiff in the upper part, soft and flexible in the lower area. This allows them to absorb energy and provide optimum protection for the occupants. Gadia, a company based in Attendorn in the Sauerland region of Western Germany, has developed a completely new production line to build such auto body components. In the past, parts that had both properties, stiffness and flexibility, consisted of two different pieces of sheet metal with different physical properties. Now a new process makes it possible for a component, like this so-called B-pillar, to be made from just one piece of sheet metal and still have both properties at the same time. It's significantly lighter than auto body parts assembled from two pieces. With TempoBox technology, we're able to manufacture auto body components with multiple strengths and properties all in one piece, and we can do this in one step. This saves energy and material during production and also saves weight and material in the car. This new manufacturing plant consists of two production lines. They can be fed with sheet metal independently of one another, and also at the same time if necessary. First, the sheet metal is heated in furnaces. Then it's molded in a large press. In order to combine two physical properties in one piece, the new production line uses what's known as the TempoBox process. Different temperature zones in the furnace are necessary for this. To create these zones, technicians slide a special template into the furnace. The template enables components to be cooled at certain points while they're still being heated in the oven. To do this, hoses with cooling water are connected to the templates. The cooling water has a temperature of around 70 degrees Celsius. It flows through the templates while heating coils heat the components inside the furnace to over 900 degrees Celsius. This technology not only produces components that are important for vehicle safety, but also increases material and energy efficiency at the same time. At the start of production, the blanks are prepared. The sheet metal has already been cut to size for the body component and is placed in a special frame. This allows several parts to pass through the production process at the same time. Robots then push these frames with the sheet metal into the furnaces. The sheets initially remain in the upper furnaces for around 5 minutes. The furnaces are heated to around 930 degrees Celsius. The intense heat in the furnaces changes the physical properties of the sheet metal. The individual iron atoms are initially bonded together in a so-called ferrite structure, which has good formability. At 930 degrees Celsius, the atomic structure of the metal changes. And during this process, a body-centered cubic ferrite structure develops into a face-centered cubic austenite structure. The robot then transports the hot steel sheets down to the lower temper box. The templates are in this lower box. The sheet metal is placed between the two templates. The templates are cooled down with 70 degrees Celsius water. In the area covered by the templates, the temperature of the sheet metal drops to around 450 degrees Celsius. As a result, the metal in this area adopts the softer ferrite structure. In the middle area, which is not cooled, the sheet continues to be heated at over 900 degrees Celsius and remains in the austenite structure. The robot takes the piece out of the temper box and carries it to the press. At this moment, it has two different temperature zones with two different metal structures. The press operates at a pressure of up to 1,200 tons. During forming, water flows into the die. As a result, the hot metal is cooled to below 100 degrees Celsius in just a few seconds. In the hot zone of over 900 degrees Celsius, this rapid cooling creates another metal structure out of the austenite. The rapid cooling, called quenching, creates a slightly distorted structure, the so-called martensite. This is particularly strong. At the edges of the metal sheet, however, there is still the malleable ferrite structure. The result is a component of a vehicle body that has two physical properties and is significantly lighter than if it had been made from two different metals. At its site in Attendorn, the company uses this new technology to manufacture over 20 different components for the automotive industry. These have the physical properties required by safety engineers, yet were formed out of one piece of sheet metal. This saves large amounts of raw materials. With TemperBox technology, we are able to save between 5 and 50% of the raw materials depending on the component. For us, this means we can save around 1,500 tons of steel raw material per year, and that amount will probably go up. The engineers continue to optimize the new technology. Their aim is to reduce the energy used for cooling as much as possible. One method is letting the cooling water flowing back from the template to cool down less. The supply and return temperatures are monitored continuously during the process. However, the cooling temperature cannot be allowed to become too warm. Otherwise, the flexible ferrite structure will not form in the cooled zone. We reduce the energy input into the cooling water, yet ensure that the product quality remains the same. Together, the temper box and the press can produce a large amount of different auto body components. Depending on which template is used, these can also be cooled in different zones. And this means that at different points, the parts can be either stiff or flexible. The engineers examine samples of the finished body parts. They analyze the microstructures that developed. Then the engineers do tests to determine the flexibility and strength of the material. This helps them to ascertain whether they can further reduce the cooling energy or even the heat input in the individual furnaces, yet still produce the material with all of its desired properties. Due to the new TemperBox process, safety engineers now have completely new design options for their work. New components are created that take safety to another level. And they do it with less energy and fewer materials.